Hello friends, welcome to this YouTube channel. Today we are going to solve a couple of simple numerical problems on fundamentals of AC. By solving these problems, we shall learn how to determine frequency, instantaneous value, RMS value, average value, etc. of a sinusoidal voltage or current. We shall also learn how to perform addition and subtraction operation of sinusoidal quantities. An alternating voltage is given by V equals to 141.4 times sine of 314t volt. We have to calculate frequency, RMS value, average value and instantaneous value of voltage when t is 3 milliseconds. We also have to determine time taken for the voltage to reach 100 volt for the first time after passing through zero value. Let us first write down the given expression of voltage. V equals to 141.4 times sine of 314t volt. This may be written as Vm sine of omega t. Therefore, angular frequency omega equals to 314 radian per second and peak value of voltage Vm equals to 141.4 volt. Let us first calculate frequency. F equals to omega divided by 2 pi, that is equal to 314 divided by 2 pi, that gives us 50 Hz. RMS value of given voltage Vrms equals to Vm by root 2, that is equal to 141.4 divided by root 2, that gives us 99.702 volt. Average value of given voltage V average equals to 2 times Vm by pi, that is equal to 2 into 141.4 divided by pi, that gives us 90.018 volt. Instantaneous value of given voltage when t equals to 3 millisecond, that is equal to 3 into 10 to the power minus 3 second. V equals to 141.4 times sine of 314 into 3 into 10 to the power minus 3, that gives us 114.3553 volt. Let the time taken for the voltage to reach 100 volt for the first time after passing through zero value be T1. Therefore, 100 equals to 141.4 sine of 314 into T1, or sine of 314 into T1 equals to 100 divided by 141.4. From this equation we get T1 equals to 0.0025 second. A sinusoidal alternating current has RMS value of 40 ampere at 50 Hz frequency. We have to write the expression of instantaneous current and obtain its value 0.002 second after passing through maximum positive value. Let us first write down the given data. RMS value of alternating current IRMS equals to 40 ampere and frequency F equals to 50 Hz. Let us first calculate peak value of current. Im equals to root 2 times IRMS, that is equal to root 2 into 40, that gives us 56.5685 ampere. Angular frequency omega equals to 2 pi into f, that is equal to 2 pi into 50, that gives us 314.35 0.1593 radian per second. Time period T equals to 1 upon F, that is equal to 1 upon 50, that gives us 0.02 second. Let us now write down the expression of alternating current. I equals to Im sine of omega t. Using values we get 56.5685 sine of 314.1593 times t ampere. Peak value of current is reached at T1 equals to T upon 4, that is equal to 0.02 upon 4, that gives us 0.005 second. Time instant 0.002 second after passing through maximum positive value t equals to 0.005 plus 0.002 second, that is equal to 0.007 second. Value of current 0.002 second after passing through maximum positive value I at t equals to 0.007 second equals to 56.5685 into sine of 314.1593 into 0.007, that gives us 45.802 ampere. Three sinusoidal voltages acting in series are given by V1 equals to 10 times sine of 440t volt, V2 equals to 10 root 2 times sine of 440t minus 45 degree volt, and V3 equals to 20 times cos of 440t volt. We have to determine an expression for the resultant voltage and the frequency and RMS value of the resultant voltage. Here we observe that angular frequency omega equals to 440 radian per second. Now we shall calculate frequency. F equals to omega divided by 2 pi, that is equal to 440 divided by 2 pi, that gives us 70.0282 Hz. Now we shall write down the voltages in complex form. V1 equals to 10 volts at an angle 0 degree. This may be written in Cartesian form as 10 times cos of 0 degree plus j sine of 0 degree volts, that is equal to 10 plus j 0 volts. V2 equals to 10 root 2 volt at an angle minus 45 degree. This may be written in Cartesian form as 10 root 2 times cos of 45 degree minus j sine of 45 degree volt, that is equal to 10 minus j10 volts, and V3 equals to 20 volts at an angle 90 degree. This may be written in Cartesian form as 20 times cos of 90 degree plus j sine of 90 degree volts, that is equal to 0 plus j20 volts. While writing the voltages in polar form, we have used their peak values because finally we have to write down the time expression for the resultant voltage. Applying Kirchhoff's voltage law, we get resultant voltage V equals to V1 plus V2 plus V3. Using values we get 20 plus J10 volts. This may be expressed in polar form as 22.3607 volt at an angle 26.5651 degree. Now we shall write down the time expression for the resultant voltage. V equals to Vm sine of omega t plus phi, that is equal to 22.3607 times sine of 440t plus 26.56 51 degree volt. Let us now calculate RMS value of the resultant voltage. Vrms equals to Vm by root 2, that is equal to 22.3607 divided by root 2, that gives us 15.8114 volt. If three sinusoidal alternating currents represented by I1 equals to 10 times sine of omega t ampere, I2 equals to 20 times sine of omega t plus 60 degree ampere, and I3 equals to 7.5 times sine of omega t minus 30 degree ampere are fed into a common conductor, we have to determine equation for resultant current and its RMS value. Let us first write down currents in complex form. I1 equals to 10 ampere at an angle 0 degree. This may be written in Cartesian form as 10 times cos of 0 degree plus j sine of 0 degree, that is equal to 10 plus j0 ampere. I2 equals to 20 ampere at an angle 60 degree. This may be written in Cartesian form as 20 times cos of 60 degree plus j sine of 60 degree, that is equal to 10 plus j 17.3205 ampere, and I3 equals to 7.5 ampere at an angle minus 30 degree. This may be written in Cartesian form as 7.5 times cos of 30 degree minus j sine of 30 degree, that is equal to 6.4952 minus j 3.75 ampere. Applying Kirchhoff's current law, we get resultant current I equals to I1 plus I2 plus I3. Using values we get 26.4952 plus J 13.5705 ampere. This may be written in polar form as 29.7683 ampere at an angle 27.121 degree. Now we shall write down expression for resultant current. I equals to Im sine of omega t plus phi, that is equal to 29.7683 times sine of omega t plus 27.121 degree ampere. Now we shall calculate RMS value of resultant current. IRMS equals to Im by root 2, that is equal to 29.7683 divided by root 2, that gives us 21.0494 ampere. A sinusoidal voltage V equals to Vm sine of omega t is applied to three parallel branches. Two of the branch currents are given by I1 equals to 150 times sine of omega t plus 45 degree and I2 equals to 40 times sine of omega t plus 90 degree. The source current is found to be I equals to 205 times sine of omega t plus 30 degree. We have to calculate the effective value of the current flowing in the third branch and write the time expression for the said current. Let us first write down the currents in complex form. I1 equals to 150 ampere at an angle 45 degree. This may be written in Cartesian form as 150 times cos of 45 degree plus j sine of 45 degree ampere, that is equal to 106.07 plus j 106.07 ampere. I2 equals to 40 ampere at an angle 90 degree. This may be written in Cartesian form as 40 times cos of 90 degree plus j sin of 90 degree ampere, that is equal to 0 plus j 40 ampere. Source current I equals to 205 ampere at an angle 30 degree. This may be written in Cartesian form as 205 times cos of 30 degree plus j sin of 30 degree ampere, that is equal to 177.5352 plus j 102.5 ampere. While writing the currents in polar form, we have used peak values because finally we have to write the time expression for the current flowing through the third branch. Now applying Kirchhoff's current law, we get source current I equals to I1 plus I2 plus I3. Therefore, current flowing through the third branch I3 equals to I minus of I1 plus I2. Let us now calculate I1 plus I2. Using values we get 106.07 plus J 146.07 ampere. Therefore, I3 equals to 71.4652 minus J 43.57 ampere. This may be written in polar form as 83.7 ampere at an angle minus 31.37 degree. Now we shall calculate effective value of the third branch current. IRMS 3 equals to IM3 by root 2, that is equal to 83.7 divided by root 2, that gives us 59.185 ampere. Time expression for the third branch current I3 equals to Im3 sin of omega t minus phi 3, that is equal to 83.7 times sin of omega t minus 31.37 degree ampere. So today we have solved a couple of numerical problems on fundamentals of AC. By solving these problems, we have learned how to determine frequency, instantaneous value, RMS value, average value, etc. of a sinusoidal voltage or current. We have also learned how to perform addition and subtraction operation of sinusoidal quantities. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.